basically binary search, what it does is instead of checking each number one by one to try to find the target, we'll be just splitting up the array into half, and if the target is on the left side, then we will be just searching for the target on the left side of the array. If it is on the right side, then we'll be searching it on the right side of the array. So let's jump on coding. So let's define our start index and end index, and we'll just need to iterate through array until start becomes larger than end. So as it's saying, so we'll need to return index, otherwise -1, so we'll be just leaving it as it is. Like I was saying, so we're splitting up into middle, so we'll need to find the middle of it. And if you noticed, we are doing subtraction, finding the middle of it, and then adding the start. So the reason why we are calculating middle in this way rather than just adding this 2 and then just dividing this number, it is because when we are adding this 2, let's say it's like our array is a really large numbers, and when we are adding, we are going into a risk of an overflow. It might exceed the maximum positive integer. So on the safer side, we'll be just subtracting it and adding the start. So let's define our conditions. So first of all, if we find the target, then we would just need to return it right away. Another condition would be, so basically shifting our array ranges. So what I mean by that is, so let's say if given number is smaller than target, that means we don't need to go to the left side of the array, because like we will not find the target, because this target will be bigger, larger than all those left side of the arrays, just like 9, and then this will be less, so we will need to look for the right side of the array. So in this case, our start will be getting updated to the middle, whatever the middle is in there. So, and then just starting from there, because like we don't need to see the middle anymore. And the same goes when the given number is bigger than target. We don't need to go to the right side, because like everything will be bigger than target. So we don't need to go to the right side. We will need to shrink it and then update the end side. So our end would be this way. So let's submit our solution. So this is a binary search. In this case, the time complexity is all log of n, where n is all elements in given nums array, and space complexity is constant, it's O of 1.